All right, we're gonna jump back into it. Did anyone think of any questions over the break or anything? I know. Cool, so where we left off, we were just looking at our goal to loop through command line arguments and add them if they're whole numbers. And we had broken that down into three kind of sub-problems. So starting back up, we'll start by defining a function. Maybe we'll call it get arguments. And this will be a function. It doesn't take in any parameters. And the idea is hopefully it will return the command line arguments from the user. So I think yesterday you might have seen one way of getting user input. And what was that? Yeah, so we had process.argv. You'll notice that as I'm coding, I'm getting these like squiggly underlines, and this is related to if I go in here and I go ESLint and do everything, I get 5 problems, 3 errors. So get arguments is assigned a value but never used, missing space before opening brace. All of these errors are coming up from ESLint that I've used in the command line to lint my code. Within VS Code, there's also a huge plethora of add-ons or extensions that you can use. Let's see. So I have a couple of extensions that I'm using with my VS Code. One of them is ESLint, and that's one thing you can do if you don't want to lint by command line. You can set up ESLint within VS Code so that as you code, it's kind of easier to code as you go, or lint as you go at least, because you'll get this like red and yellow syntax highlighting. So it wants a space after that one. And these 2 yellow ones are because I haven't used those variables yet, which is fine because we're still coding. So if we're getting process.argv, let's just return user args. And so now we have an approximation of what our function will do. So at this point we can test it. We'll just do a console log of get arguments. So I have defined the function here, and then I'm calling the function inside of a console log just to log to the terminal whatever this function will be returning. So now I can go node sum numbers.js, and I see this being outputted. Or if I go sum numbers and I give it 10, 20, 30, I get an array with looks like a path, another path, and then 3 numbers. So if you've used process.argv before, you'll know that it takes in everything that is entered into the command line. So the first thing that I've entered here is node, and the command line knows that node is a thing that exists here. So when I type in node, I'm actually typing shorthand for the program node which exists here in my computer. Same with sum numbers. It is a file that exists in a certain path. So process.argv is going to give us this, 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 and this. So right away, we're trying to get all of the user inputted arguments, and we see that we're getting these 2 extra things. So before we even get kind of deep into our problem-solving process, we've identified an early error that we can fix just with our getArguments function. So to fix this, There's a couple ways, but maybe the easiest is just to do a dot slice. And dot slice takes in one parameter, which is the index or the position in the array that we want to cut the array from. So if we say process.argv.slice2, and we save that, and we run our program now, now we only get 10, 20, 30, because it has sliced it from 2 onward to give us this new array. So 2 being that third thing in the array, because we start our indexing at 0. So 0 thing, 1 thing, 2 thing, and onward is what our slice is getting us.
Would it be different if we change that constant to that, like the constant before the function name?
So here, what happens if I do this?
Also the function name. Yeah.
This one. So nothing will happen with our code. What is our understanding in the difference between let and const at this point? I know it's something we probably haven't gotten into too much. The main difference is that const is a variable that is not going to be changed or altered, whereas let is a variable that we potentially will be changing in the future. By standards, when we're creating a function, you always want a variable or initialize it with const, because this function shouldn't be changed. Like it's a thing that's going to do some actions for us. We don't want to have it changed down the line. The only difference is if we go maybe I'll leave this how it is. I'll do another thing here. If I create a new variable const thing equals dogs, and then after that I try and say thing equals cats, and I try and run this, I get this error, assignment to constant variable. So when I declare things with const, JavaScript is going to work against me when I'm trying to reassign them. It's like, you told me that this wasn't going to change. Why are you changing it? Whereas if I do let and I run that same code, I don't get any errors because I'm okay. It's okay with me changing a let variable. You'll get, there's a little more to let and const than that, and you'll see that in another lecture this week. But that's kind of the bare bones of it. Let are variables that we will be wanting to change. Const are variables that will remain constant. And in this case, I know I'm just going to use these. I'm not going to change them. So I usually default to const. And then if I get that error saying like, hey, you changed this thing that was const, I'll go back and change it to let. That's my pattern. I'll just use const, and then if I have to, I'll change it to let. Okay, so now we have this one. We can kind of check off our first action or our first thing that subproblem that we wanted to do. And whenever we finish a part and it looks good, that's a chance for us to add and commit. So we can do add everything, git commit, and then we'll add some form of useful comment. Added function to get user arguments. And then we have that one commit added. You don't have to push with every commit. If you do a push after 5 commits, it'll take all of those 5 commits and push them to your remote. So in this case, that was like a smaller commit. I know I'm going to continue working on this project, so I'm not going to push right now. Maybe I'll push when I've completed more. So next thing that we wanted to look at was to check if our input is a whole number. And if it's not a whole number, we were going to skip it. So again, we'll create a new function, and we'll call it check like wholesomeness. And this time, it's going to be run on like a number. So we'll give it one parameter that we'll call num. We'll do a function declaration or functional expression the same way that we did up here. And then what do we want to do inside here? We want to take that number and verify that it's a whole number, but what does that involve? What is the first thing we should check before we check if this thing is a whole number? Yeah, if it's a number. So first we want to check if it's a number. There's usually a couple ways you can do things in JavaScript. One way we can do this is we can go is a number, and we can do something like this. So what's happening here is we're using number, which is a keyword within JavaScript referring to the number object. And by itself, it is a function. Given anything, it will try and convert it into a number. So if we give it 10 in quotations, it'll try and convert it to 10 as an actual number. If we give it a string, it's going to try and do its best. And maybe we'll first check how that works. So similar to before, we'll just do a console log of check wholesomeness, and we'll give it some test values. So first we'll give it 10. And then maybe we'll give it just like some random string. And then lastly, we'll give it like an actual number. Oh, this is going to do something interesting, but we'll check. So we get 10 NaN, so not a number, and then 12. And then we have undefined, undefined, undefined. The reason we're getting undefined, undefined, undefined is because I'm console logging the result of this function, and this function isn't returning anything. I'm just console logging inside of it. So if I want to get rid of that, I could, instead of console logging here, I could leave the console log to this one, and I can just return is number maybe. It would be the same thing, but without the limit. So we have 10, not a number, and 12. So that's good. What is a property of not a number that is useful to us? Yeah, it's not a number is falsy. So it being falsy means that we can use it as a conditional, or we can do a check based on is number. If I go if is number, and I maybe just console log, it's a number. If this is a real number, so like 2, 3, numbers are truthy. Most values, except for a few in JavaScript, are truthy. One value that is not truthy is not a number. So our check here, if it's not a number, this won't run. If it is a number, this will run. So we can run the same thing again, and we get these only being printed out when it's actually a number. So we've got our first test to try and get wholesomeness, or trying to get whole numberness. We know whether a thing is a number or not. But we also need to check if it's a whole number. Does anyone know how we could check if it's a whole number? Is whole? It's kind of similar. Yeah, that might be a way of doing it. Is whole. So another thing that we can do is we can use this number keyword, and we can use another function that it provides. So we can go number.is, and whole numbers are integers. And we can call that on maybe is number. And this will just check if it's an integer, which is a number without a decimal point, or if it isn't. And then maybe we'll check if it is a number and also it is whole. So if we then run our test and we give it some, maybe 10 as a whole number, 20.5, 30.2, we get, wait, what? Oh, yeah, because we're using these numbers here. So we have to change these test values. So we'll go 10.5 and we'll keep 3 as a whole number. So we only get this being printed for the last one, which is the behavior that we want. So now again, we've taken a small problem and we've kind of like narrowed it down to doing the thing that we want to do. But because this is a function and we want to keep to like functional programming, we want it to give an output instead of just doing like a console log. So if it is a whole number, then we want to do something. And if it isn't a whole number, maybe we want to do something else. This is where we have kind of some options depending on how we want to see our program going forward. One thing we could do is we could say, okay, if it is a whole number, maybe we'll just return that number itself, like the whole number that we got. So if it's a whole number, then is whole will be the number because we've run it through converting it to a number and then converting it to an integer, and we can return that. But in the case where it is not a whole number, what are some things that we might want to return? We could do an error message. So we could go like new error. That might work. And so now, sorry? That's another option. So we can go, we also return the number 0. And that's a nice way of thinking because in the context of our problem as a whole, we're getting an array of numbers and we're looping through them to add each number only if they're a whole number. So if we return an error message, this might be appropriate for some functions and would give the user some more information. But then we would be returning sometimes a number, sometimes error message, and would have to do checking after the fact to see which ones will add, which ones are errors. Whereas if we just return 0, whether or not we return a whole number or we return 0, we can just add them together. Because the 0 will have no impact on our sum that we're totaling, whereas the whole number will. So at this point, we're at another kind of like checkpoint. We can do a quick add and quick commit function for checking whole numbers. And I know like this, it seems like I'm committing a lot. You might be committing less in your real workflow, but it's more to like illustrate a point that we do want to make it a practice of committing throughout our programs and making sure that they have meaningful messages so that if we look back on this history thing, we can see the lifespan of our project in meaningful chunks, not just like, you know, I could just git commit -m Monday, I guess it's Tuesday now, Tuesday morning. And then like, maybe I don't commit for like a huge chunk of time, and then I do 3 commits back to back with like very little changes. Those would not be as helpful as like smart commits according to chunks of code that you've added. Okay, so this one, we've kind of done a bit of error checking. Seems like it's performing the way it wants. So we'll get rid of these, and we'll move on to the last subproblem that we had. we want to add the numbers. So again, we'll start with the function, and we'll go add whole numbers. Well, I guess it's probably just going to be able to add numbers in general. This will be a function. And what should our input be this time? Yeah, we'll probably be using this and this thing. If we want to make it more general and we just wanted to be able to add numbers in general, yeah, maybe we'll call it add whole numbers. What could be an input for it? Like if you want to add a group of numbers, how are groups stored within JavaScript? Arrays, yeah. So we can maybe give it maybe we'll call it like a num array. And so we know that at the start, we're going to need to eventually have a sum. We'll initialize it at 0. And then we're going to need to loop through this input and somehow add them all together. So with loops, we've got a couple options. We could do like an old school, like C-style loop, where we go so where we're initializing a 0, we're going for the full length of the array, and every loop in, we're adding a new thing. This would work, but there's also a maybe cleaner way of looping through arrays in specific with JavaScript, and that's something called a for of loop, and that will look like this. So the way this is formed is we first initialize a variable of our name choosing, so I've called it num, and then we say of an array. This num array here, or whatever you pass in as the second thing for your for loop, has to be an array. What this loop will do is it will loop through, let's maybe do an example. So if we have a test equal, and then we go, our array in this case is test. It's going to loop through this array, looking at each element one at a time, and saving the current element that it's looking at to this array, or this variable that we've assigned here. So if we create the loop like that, and then we just do a console log of num. Hopefully I don't have any errors in that thing that we put up there. We'll get 1, 2, 3, 4, 45. Because what this for of loop is doing is it's going through each element in the array in turn. It's putting that in this number variable and giving it access to it within this loop. Whereas if we did this, oh, I erased it, but if we did the other type of for loop, we would have had to go test square brackets of like x or of I, of whatever our placeholder was, to get, say, 2, and then 3, and then 4. So this is just a bit cleaner way of doing things for when we're working with arrays. So in this case, we're going to loop through each number of the array. And at this point, I want to introduce you guys to a new tool for kind of debugging. I mean, there's a tried and trusted console log. It's going to be used so much by you guys, and we could, console log num. We could console log num, and we could also see what num array is, like any information at this point. Another option that is very helpful is to use the node debugger. So to use the node debugger, I just put debugger on the line. I will need to, of course, run this function for it to do anything. So add whole numbers. Debugger will cause a breakpoint in the code and allow me to inspect the code in a more meaningful way when I run my program with inspect. So if I go node inspect and then some numbers.javascript, when I hit enter, it's not going to run the code in the normal way. We see all this extra text coming up. And by default, the debugger is going to stop at the first line in your code. So this little arrow indicates that we're on line 1, and we can see lines 2 and 3 that have those comments from our code up here. And then I have a console that I can enter stuff in. The commands that I can do, I can write next, and that'll just put me to the next executable piece of code within my program. So we jump down to line 4 because it's defining the function. I can go next again, and it will start running this. I can go next again and slowly line by line go through each thing in my code. The other thing I can do is I can do cont for continue, and it'll just go to the next breakpoint. So I don't necessarily want to go like line 1, line 4, console log, line this. If I go cont, it will take me right to the next debugger that I hit. So we've run all of the code, and it's stopped for me where I put this debugger. Where this becomes useful is I can use another command, REPL. So this stands for read, evaluate, print loop. This is similar to if you write just like node within your command line to be able to write JavaScript. I hit enter, and I now have like a JavaScript read, evaluate, print loop, or a JavaScript console. I can do just normal JavaScript if I want. I can just like console log, and that'll work. But this REPL exists within the context of my program. So this is where it becomes useful. Where this debugger was triggered, I have access to everything that I would have access on this line within my code. Meaning I can go here and I can look at what is num right now. And I can see that, oh, num currently is the value 1. I can look at num array, and I can see, oh, that looks like this. I can even think back to this function, because it will be within scope of my function. I can say, what is get arguments? Ooh, get arguments is not defined. No, it's not. We'll explore that in a second. We do check wholesomeness. So it looks like our scope is a little more narrow, because if I were to use either of those here, I would have access to them. And I'm spelling them correctly. If I hadn't passed arguments to them, it would be looking for the function by reference. So it would be just checking if does this function exist as a thing. It wouldn't be trying to call it. If I do this, I get the same thing. Check wholesomeness is not defined, which is, to be honest, quite new to me. I would really have thought that that would be accessible. But I guess our scope is a little more limited to just a local scope, meaning the local scope of add whole numbers is only between these things. Check wholesomeness and the other functions are defined within the global scope. So it's not accessible right here. But I could get some. It's 0. And if I want to exit this, I can just do dot exit, I believe. The other thing, given that this debugger was within the loop, it'll be triggered multiple times because that loop will be executed more than once. So if we run this again with inspect and I go continue, we'll hit the debugger for our first loop. Then if I go continue again, we'll hit the debugger for the second loop. If I go continue again, and then eventually after we've got everything within that loop, we'll no longer hit this. And when we get the message waiting for the debugger to disconnect, it means our program's finished executing everything that it can. And then we can get out of here.
It's not possible then to read global variables, right?
No, it doesn't look like that. I'll double check. I mean, the other thing that we can check is so I'm just converting the global object into a string so we can see. Circular structure. Yeah, I'm sure you can get the global variables. I'll look into it and I'll add it to the notes. But right now it looks like just with basic variable names, we can only get the local scope for our thing. I mean, again, I'm sure you can do the other one, but it's still helpful. Like if we wanted to add a debugger up here to check the global stuff, we could, and we'd be able to see check wholesomeness, because check wholesomeness is a global scope, but it's also local to this debugger. So even if we can't get it within a smaller scope, we would be able to get it there. Okay, so that's a useful tool for checking out and peeking into our code. Yeah.
So just want to clarify. So when you add a debugger to the code,
Mm-hmm.
your code just stops running here, and then once you type RETL, you can have access to all the variables or functions that you can access to within the code.
Yeah. So anything, if I could do a console log of array here and it would work, I should be able to. The exception that we just saw is that if I'm trying to access something outside of local scope. So local scope is if we move down and up from any line of code and we find the nearest enclosing like function, or so like curly brackets is a good way. This will be the local scope for, like, say this sum variable. If I try and use sum outside of here, it will be undefined because it only exists from here to here. So within my, like at this point, I can use sum, I can use num, I could use numarray because they're all within this function's local scope. These functions up here are in scope, but they're outside of local scope. And it seems like the debugger is making an exception for that. Again, I'll check and update your notes for that exception. But in most cases, like you'll be using like local things anyways. Yeah. So with what we're doing here, we now can loop through each one, and we want to maybe add the number to the current sum. But that would be if we were just doing a traditional like tally or a traditional sum. In our case, we only want to be adding stuff if it is a whole number. So we can use the function that we already created, check wholesomeness, to add only whole numbers to our current sum. So we could go sum and then plus equals, and what do we want to add to the sum? Yeah. So we can go check wholesomeness, and we want to call that function on the current value that we're looping through. So that would be num in this case here, or like we could call this, maybe because we don't know for sure it's a number, we could call it element. And our check wholesomeness function, again, is going to return a 0 if it's not a whole number, or it's going to return the whole number itself. So as we loop through, we'll be adding 0 or a whole number. After the loop finishes, we could return the sum. So now we can do another test kind of on our last piece of the puzzle. We'll console log the return of our add whole numbers function, and we'll give it a little more interesting test information. We'll give it 1. We'll give it
In this solution, we are accepting numbers and also strings of numbers, right?
Yes, because when we get command line arguments, they're read in as strings by default. So our wholesomeness check has to do a conversion of strings and numbers into numbers, because by default this user arguments that we're getting here will just be an array of strings. It doesn't read them from the command line knowing what type they're in. So we have 2 whole numbers, the rest kind of just junk. And if I get out of here, and I'm going to run it just without inspect, we get 2 outputted, and this we must be doing a console log. Okay, so let's run that again. We'll get the same thing, but a little less cluttered. So we're just getting the number 2 outputted. And if we look to our test, if we add all of the whole numbers here, we should be getting 6, but we're getting 2. So that doesn't make sense, but we can maybe add a debugger back in to do some investigation.
Why did you add the element in the bracket? Let's check wholesomeness and it says the bracket element.
So we're using our function and we're calling it on element, which is each thing in the array that we're passing it to. So it should be 1, this, dog, 5, 5.5. So, I mean, in this case, we know what we want to look at. So I would honestly just look at the sum, and we want to maybe output the sum and the current element so we can see how it's behaving. So the sum is 1 because we added 1. Sum is this because we added this. The sum is dog because we added, again, these would be 0 values, so we're adding nothing. And then the sum from returning 5, we now have 2. 5.5 doesn't add anything, and 2, this is the last console log. So it's only adding things when it is a whole number, but it's just adding 1 each time. What might be the problem here? Where should we check next? yeah, so let's maybe take this. I mean, we could do all three things if we wanted to. So we'll run it again. We have that check wholesomeness in this case is returning true. In this case, 0, 0. In this case, true. And when we add 1 with true, apparently we just get we get 2 higher. So it's acting as a number. So now we've discovered that, well, check wholesomeness maybe wasn't working the same way we thought it would. Because here we're checking number.isInteger, and we're checking if the number that we give it is an integer. And this looks like it's returning a true or a 0. Actually, it'll probably be returning a true or false, because if it's a false, would be returning 0 here. So instead of returning is number, or sorry, instead of returning is whole, we probably want to return is number, which is the conversion of whatever we give it into a number. And if that number is a number, and if that number is whole, then we can return the actual number as opposed to like a true or false. Yeah.
So if we actually fit the statement that is number and is whole, why don't we just return the number? Like just return number? Because if like those two statements they're false, then we just return 0, right?
Yeah. So another approach might be let's do this. The problem we're going to run into if we do this is the arguments that we're giving to check wholesome are kind of the raw information from our, well, currently they're not, but we want them to be the information from the command line. And we just saw that these arguments that are read are by default strings. So if we, I mean, this would probably get us closer. Like if we save that and run it, it would work for this case, I believe. So we get 6 because we're returning 5, returning 1. I'm going to get rid of those. And 6 is what we want. But if I go like this, and this is what the command line argument would look like, it would be a number wrapped as a string. What's going to happen is I get 150 because I start with a number, 0. I add another number, 1, and so now sum is 1. And then I add a string onto it. So the number 1 plus the string 5, it'll convert both to a string. That's how JavaScript is going to default to. So now I get the string 15. And then finally, this one is 0. So it's adding a number 0 onto the string 15. So we get 150 being outputted. But this is like a smart way to check, because like you said, it's simpler if we can just deal with one thing. But in this case, we do want to use is number because it will be the converted number. It'll only ever be like an integer in this case. So if we run this on that same test case, we'll still get 6, even though this 5 is a string. So we're kind of rounding the bend now. We've got our 3 functions. They all seem to be kind of working now. We had to do a little bit of correction to check wholesomeness. The last step is we just need to bring them all together. So add whole numbers is already working with our check wholesomeness, but we still need to get in user arguments. So what we can do is we can say, so a new variable, user arguments, is going to equal our call to get user or get arguments, which doesn't take any parameters, and will return whatever we type into the console. And then with this new array of inputs, we can call add whole numbers, and we can pass it the user arguments that we just got. And maybe we'll save this to a total. And then lastly, we could console log the total. So let's do a test. Okay, I'll do 12, 5. What else should we put in there? What else? I mean, like, oh, let's do a like decimal. This is 5.5, but oh, there you go.
Maybe a negative number?
Oh yeah, we haven't done any testing for negative numbers up to this point, so it will be interesting to see. So beforehand, 12 plus 5, 17, minus 3, we should get 14. But let's see. Oh, I put 37. So yeah, 14. Looks like it's doing good. We could run some more tests. Let's see, negative 5. Does it make a difference if our decimal is negative? Oh. What happens if we add another 5? 37. So it looks like we're doing pretty good. And then maybe that calls for a nice celebratory commit. Cool. Before we leave this code, any refactoring that we can do? Is there anything that stands out to anyone? Like, hey, I would do this differently, or I would clean it up in a certain way, or anything like that?
Just put the last two lines, like
These ones?
I mean the second, like 28 to 29. Just put those as extensions.
These ones?
Yeah.
Like I could go. Yeah, and I could even put this inside. I could also do something similar up here with my 2 checks. I could put them in line. In general, those things, like as you get more comfortable with the flow of what's happening, are good to do. I think initially, if you want to separate it out into a couple different steps, just because it's like, oh, I understand that first we're getting the user arguments, and then we're summing it into a total, and then we're console logging it. It's okay. But yeah, like this might be a little more elegant to do it. It's a single line. It's not too long of a line. But don't feel that you always have to like collapse your code into like 1 or 2 line statements, especially when you're starting off. Make sure you're understanding it over getting something that's like super nice and clean. But this would be a good improvement for sure. Nice. So let's just kind of reflect on what we went through. So we broke down our solution into smaller steps. We wrote in small steps as we went. We linted our code as we went. I didn't use it via the command line, but I did use it via that VS Code extension that we saw. And in general, it's good to lint as you go, because linting isn't this thing that like you do for other people necessarily. It's not like, oh, I finished my project, I'm gonna lint it, so then when I submit it to like person A or B, my code will look nice to them. Linting is also very important just for like your own like state of mind. as you're going through your code, if it's messy, it's going to make it much harder for you to program. It's going to make it harder for you to find certain things. So linting as you go will create a nice clean space for you to continue coding in. We kind of like avoided copy and pasting any code. We didn't really do any looking up. I mean, we could have done some looking up on Google for checking out, maybe a whole number check. But in general, if we had, it's nice to avoid copying and pasting so that we can have an understanding of the code. If we just take something that someone else has done and put it right into our project, not only can that later on, be at risk of some plagiarism depending on how much code we've taken, but it can also, it doesn't help us in understanding what we're doing. So of course, look for resources online, find stuff and solutions that other people have done, but let's take the extra step to kind of understand what it is they're doing. We committed often every function that we finished. We used console logs to understand our data. We also used the node debugger. In general, when we're debugging, that's going to be kind of most of your time in programming tends to end up being debugging. You get a lot of stuff done, and then you hit a wall. And you just kind of like sit there for a while, spinning your tires, trying to figure out what's wrong. And then you break through, and you get a whole bunch of other stuff done. And then you hit another wall. So getting good at debugging is a really big and valuable skill that you'll be developing as you move forward. In general, errors are your friend. When your console spits out an error, that's kind of a good thing because it's going to give you some information on why that thing is occurring. If it's a syntax error or if you did something wrong in your code, you can look to it, find the line, and work backwards from there. You could also hit other error types like logical errors. So a logical error that we saw in our program was our check wholesomeness was returning true instead of a whole number. So those errors can be harder to debug because our program is working, it's not crashing, but it's not doing our intended like result. It's not performing the way we want it to. So that's when we would probably fall back to using more things like console logs and the debugger tools that we have available to us. Like our typical research path, you're gonna like maybe Google for a question. Stack Overflow often comes up. Stack Overflow is a good resource, but you have to also keep in mind that the people in there are thinking, what is like the optimal solution for things? Not necessarily what is a solution that is good for the masses or a solution that people will understand. So the first thing that comes up on Stack Overflow might not always be your best choice. Search around a bit. You can hit this case where like the answer you find is like in a weird, complicated syntax that you've never seen, and it's going to take you like forever to understand at this stage. If it seems like that, look other places. You don't need to like, there's many ways of doing things. You don't need to get caught up on the first one that comes up. Yeah, you can have a parsing or runtime error. Get comfortable reading those error messages. For logical errors, take it back a step. Do a dry run of the code in your head. Look through, okay, we gave it this thing, it did this step, then this happened. Logical errors are also easier to isolate when we do this, compartmentalized coding, when we do step-by-step problem solving. If we had tried to do all of these things in a single big function, it would be much harder to debug logical errors. Yeah, and as a reminder, like the mentors are here to help when those things just aren't working. 15-minute rule, if you've been working on something for 15 minutes and like just haven't made progress, like flag a mentor. And don't be like shy about doing it. The mentors here will be very happy to help, and it'll help you in the long run. But like flagging mentors is also a skill that you'll develop over boot camp. Like just saying, I don't know why it's not working is not the most helpful thing. Try and think of how you can explain what's happening, what is the context of the problem. You don't have to be great at this at the start, but as you go down, you'll get better at kind of narrowing your problem description and being very maybe accurate with what is going wrong. Use your mentors not only when things break, but also as a resource to do code reviews and to explain topics that are confusing or that you don't quite understand. If you're working through some material and your code is working, but you're not exactly sure why it's doing a certain thing or why you should do something a certain way, that's also an opportunity to like ask mentors for help. They're not just there to like help when things explode and break on you. Lastly, one thing we'll look at is a resource called JS Tutor. This is something you may or may not use. Some people find it really helpful. Some people don't. But it is a tool for visualizing code. So we'll copy these last two functions. I will paste it within this JS Tutor. And then maybe I can go add whole numbers, and I'll just pass it an array of a couple things. What JS Tutor is going to do is let me visualize the execution. So if I hit this, it's going to try to run my program, and just like we saw with like Node Debugger, it's going to break at the start and then let me step through the code one line at a time. So this red arrow indicates at what point in the execution I'm at. I can come down here and go forward, and it will run the next thing that it can do. And as it's doing this, it gives a representation of how the data is being stored within my program. This can look a little complicated, but like don't maybe overcomplicate things. We see that check wholesomeness is a variable we created, and inside of it we stored a function. Add whole numbers is a variable we created, and inside of it we stored a function. Same with num array. It's a variable that we created, and inside of it is this array. And then sum is also a variable, and its current value is 6. As we step through this, we'll see that it ended because it wasn't. The values we have within here will be updated as the program goes through. So our sum starts at Our sum starts at 0, and then forward should just bump us to the next thing. I'm not sure why we'll just go like this. So it starts at 0, and then as we loop through, we can see that number, which is represented as each thing in the array, changes, and our sum gets updated as we progress through our code. And this bottom block that pops up is showing us the check wholesomeness function, its local variables, how they're being stored. So if you really want to see how things are executing, see this red arrow bump around. This can be helpful. It also helps build an understanding of how things are stored in memory. But it's by no means necessary. Only use it if it's something that's interesting to you. The link will be in the notes for you to use, as well as anything else we mentioned. Yeah, any questions before we wrap things up?
Would you be able to send actually all that code to us?
Yeah, so that's with every lecture, you will get notes afterwards sent to you by the lecturer. And if they did a coding exercise, they should be sending that code within the notes too. So I'll get that out to you like within an hour or so. It'll have all of these notes as well as the code that we that we work through. And that'll be the pattern that you'll see throughout the bootcamp as well. Cool. Thank you guys, and I'll be around. So if any questions come up about any of this material, just let me know. Yeah.
I don't really understand the debug thing. I don't know like how it works and what I can get, what information I can get from the debugger.
From this, yeah?
So actually, I don't know why we like put the debugger into the function. Why?
It's just so you can, like anytime you would be console logging something, but you want to do a little more investigation, if you put a debugger, you can inspect everything that's around it. So you can inspect his number, his whole, and you can run like a function, like if we had a function here. And we just so when this debugger gets hit, so right now we're here, I'll go continue. Oh, I need to give it some arguments. So I'll go continue. I hit that debugger. I could like run this function. So I could go
This function.
I could go REPL, which lets me run JavaScript, and I can go my test, and it'll run that function. Or I can look at is whole and see what its current value is. I can look at is number. So it gives you access to all the variables and functions and everything that you have within the code at this point.
At this point, like the code before debugger, or the code.
Well, whatever the scope would be of the debugger. So it could be code before or after, depending on how it's been run.
Like for right now, for the code, to go to the code.
Yeah.
So for now, we are debugging like it's inside. Where's the debug? Oh, so here it's testing only this function.
Well, this whole function here I have access.
Oh yeah,
to.
this whole
So
function.
that's why I could use is number, is whole,
so
my
you
test.
and you do the and you put the debugger here, so it can. I still don't really understand.
I mean, it's not doing anything magical. It's just the same. If you find yourself going console.log of like is number and like a bunch of things, like you just want to see what the values are while your program is executing, you could do this approach, or you could do this approach where you like use the debugger in order to look at these things. It just lets you insert, like, the debugger pauses here and lets me write code as if I was here. So right now, in here I did my test is whole and is number. It's the same as if I did my test is whole and is number. Like it lets me insert new code in here for testing, like as the function's running. And then I could continue to the next. Yeah, next time that debugger is hit. So where.
Yeah. It's very difficult for me to understand it.
Mm-hmm.
It's like how it works and what's the use of the debugger.
Like it just runs your program,
Runs like
and then it
like
lets you stop at any point and test code if you want to.
test code.
Like you can write the code that would be here. Like you can move this anywhere you want. If we put it here, I run it again, and then I go continue, which will continue until it hits
so
the next
what's
debugger.
this like? What does it show like?
It just shows
at this point.
where the debugger is at. So the debugger is at line 1.
At line 1.
Yeah, and so I can't do anything at line 1, so I want it to continue, and then now it's at line 30.
Line 30, and what information can you get from so far?
Well, I can get, it's not what it shows on the screen, it's depends on where the debugger is here. So at this point, the debugger has access to all of this.
Yeah.
So I can go, I can look at check wholesomeness, and it tells me that it's a function. Or I could call check wholesomeness on, a number, and it'll return thing. It's just a way of testing the functions and variables that you have at this point.
Oh, it's like just check the code. Like you can like put some argument to try whether that function works.
Yeah. Unless you're unless you're error checking, you don't really use it.
Oh, okay. 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 Thank you.
No worries.